we're looking at language processing. Under it, I say we're going to look at syntax, semantic analysis, naming, and binding. In the previous class, we discussed something that has to do with language design considerations. And part of that language design consideration involved syntax and semantic analysis. What do we want this language to be like? Who are our target audience that will use the language? How do we set the rules? Because syntax is talking about rules, while the semantic is talking about meaning of whatever you are writing. So we stated that when you are designing a language, particularly for something, you are going to be able to streamline the syntax of that language based on your desire, or rather what you want to achieve with the language. So you see some languages, some of them are simpler, some have the dynamic typing approach, where if you don't declare the meaning of the type of a variable, the thing still runs. And then there are other languages that must uh, require you to declare the type of that variable. So looking at what you want to achieve with the language is one of the reasons why, or one of the things that inform how a language is designed. Now, we are looking at how languages process your code, how they process your code. Now, it begins with the syntax. How does the language see the syntax? And how does it process the semantic? How does it pass it before it generates the machine code? Okay, because at this point in time, we are actually talking about high-level languages like those languages that you compile or the languages that you interpret using an interpreter. When we talk about interpreter, we are dealing with scripting languages because those languages are actually interpreted. Now, when you are talking about the executable file, that means you need to compile the language, the compiled languages that must be translated from the high-level operational code that you wrote into the code that machine understands. I don't know if it's in this class I talked about, or maybe in the maybe it's in that video class that I talked about translating from the high level to coding. That machine usually understands only zeros and ones. And I talked about why machine understands zeros and ones, because they are built with electronic devices, and those electronic devices are switching devices. Now, when they are switching, they are only switching from 0 to 1, 0 to 1. You understand? You must have learned bipolar transistors. Have you learned anything about transistor or diode in your physics? So, when you are talking about diode, you are talking about something that has two polarities, the negative or the positive. So you have the PN junction, positive junction, and the negative junction. Now, if you connect another half of the diode to the other end, you have what is known as either PNP or NPN. So you have, if you have it that way, you already have what is known as transistor. And that transistor can be NPN transistor or PNP transistor. I'm not talking of electronics now. The issue I want to bring to you is that the fundamental operation of the computer circuitry is about PN or NP, positive or negative. So even if you are seeing a flickering on the computer interface, whatever you are seeing on the computer interface is just a manipulation of zeros and ones. Are you getting what I'm saying? So, even if you write a language like Java in an understand that a high-level language that humans can read, the system will still have to bring it back to what the computer understands. Do you get what I'm saying now? So we talked about, in that previous class, we talked about language progression, that it first started with machine codes. Okay, the code generated by machine, zeros and ones. I talked about these are codes that are very, very closer to the machine itself. That's the hardware. Then the difficulty there, machine understands it easily because it is in the language that machine understands. That's machine language. But it is very, very difficult for you to understand. For instance, if I ask you now to write your name in machine language, you know it's going to be difficult because you first of all are going to do ASCII translation. What is that A in your name? What is the number? What is the ASCII code? Now you find out it may be 001100 before you get your A. And then, so before you now write your full name, zeros and ones are everywhere. So it's very, very difficult for you to understand. And he progressed to assembly language, where those languages, those repeated things that you do in languages are moved to symbol. For instance, there's a point in your programming that you may need to jump from one place to the other place. Are you getting me? Now, if you write that in a machine code, it's still going to be zeros and ones. But to make it easier a bit for humans, that zeros and ones are converted to maybe JMP. Are you getting me? So when you are writing as assembly language, if you want to write jump to this place, you just write JMP. It's just a symbol that will encapsulate those zeros and ones. Yet it is still difficult. It is still difficult for humans to write it. And then we progress to high level languages where you have human readable languages. You can at least look at the thing and say, okay, this thing is talking about if then statement, and at least you can read it. But you understanding that language will also need you to understand what addition means, what plus means, how it is done. And those how it is done is called the syntax of the language. That is how we combine things to work together. It's called the syntax of the language. Now, if I combine these things this way, what does it mean? It's called the semantics of the language. Are you getting me? So, syntax talks about rules for language presentation, while semantics talks about how we understand what is written. So I want to take this as a recap of that class, but please, I would plead with you to make sure that you watch that video. Now, we have graduated from the design consideration because after introducing that, when I talked about design consideration, the person that is developing the language, what does he have in mind in developing how the syntax works and what some certain things mean? And also, the developers that are using the language, what do they have in mind in choosing a particular language for a particular project? Are you getting it? Now, let's look at syntax. Now that you have understood that there is syntax in languages and there are semantics in languages, how are these things analyzed? How does the system, it's one thing for you to know that you assign variables by putting the variable name, this and that. But there has to be that on a deeper understanding because you are in software engineering, a deeper understanding of how things work behind the scene. Are you with me? So we look at language processing. Now, language processing refers to the series of steps or phases that a programming language goes through to transform high-level code written by developers to machine-readable instruction that can be executed by the computer. That is just what this thing means. Okay? So by the end of this lesson, there are two things I expect that you go home with. Number one is that you should be able to describe the process of processing a language. The process, if you write a code now, what process it passes, the processes it passes, you should be able to understand it before the output of whatever you wrote. Okay, number two, I want you to understand or to be able to explain what naming and binding means in programming languages. and also to be able to spot the difference between naming and binding. Because when we start talking about it now, you may be confused that I'm talking about naming, I'm talking about binding. Are they not the same thing? Are you getting me now? So you should be able to know what naming is and what binding is, and should be able to tell the difference between the two. The graph, or rather the chart you are seeing, okay, please, I've sent that into your email, to your WhatsApp. Have you seen it? Have you sent it to them? So that when I'm maybe pointing at something, they are also looking at what I'm looking at. Okay. So what you are seeing, the chart you are seeing is a process. So you see a big arrow behind the boxes. Okay. So it's an arrow that quickly tells the steps that you follow to get a language processed or your syntax processed. Okay, the first thing is one, lexical analysis. Number two is syntax analysis. Number three is semantic analysis. And then we talk about code generation. Intermediate code generation. When we have generated the code, we optimize the code, and then we generate the main code and link and bind the language, bind the code. Okay. What then is lexical analysis? What then at the section of lexical analysis? What does it mean? What does it mean? We say that the primary goal of lexical analysis is to read the input source code and break it into smaller and meaningful units called tokens. So when you write int age is set to 51 semicolon. Now, at the point of lexical analysis, those things are broken into int is a token, then age is a token, equality is a token, and so on and so forth. So at the first point, the first step, what happens is that the source code is scanned from that left to right. This is not like Arabic. You know, Arabic is read from right to left. So the input source code is read from left to right, just like your English language. From left to right, and individual elements such as keywords are identified. Now, what is from that example that I gave, int age equals 51, semicolon. Now, the question is, what is int? What is int? The int is actually a keyword that we use to represent the type of integer. Are you getting it? Now, sometimes when you write it, it's not sometimes, almost all the time, when you write it, you give space. Are you getting me? Then you write the name of that variable. That is the variable name. Then the equality sign is what? Is an operator. And then you have the value that you assigned and the semicolon. So when you scan from left to right, you will spot individual elements that are, or rather that may be keywords, operators, identifiers, and literals as recognized by that language. I get it? As recognized by that particular language. Because what may be a keyword in Java may not be a keyword in C++. Are you getting me? So I want to believe that we have done design consideration in language, and we've talked about how they generate their syntaxes and semantics as concerns that language. Now, when that thing is broken in pieces, what happens again is that a lexical analyzer will do what? Remove the white spaces, and the comments and irrelevant characters from the code. For instance, if you write int age, of necessity, there has to be a gap between the int and age. Otherwise, it will treat it as one variable name. Are you getting me? So, and it will become int age instead of int age. Are you getting me? It will become intage, and the system will treat it as one. Now, although that you meant int age, when the system, the lexical analyzer sees int to say, okay, this one is a keyword, we put it in a table. We remove the space, you know. So you will just discover that when you write int age equals, maybe you put space before 51, the system will still understand it, isn't it? So why is it so? It is because there is something in the language that removes the white space and take the relevant characters. Are you getting what I'm saying? So that is why even if you put 10 spaces before you assign, it will still take it. It understands. It has a system of removing those spaces. That's what the lexical analyzer does. Now, those tokens are categorized now. When it separates them, it will now say, what is int? It will go to the database of the designers when they design the language. It says, do we have int as keyword? If we have int as keyword, they put it as keyword. Are you getting me? And so on and so forth. So it will identify those places. The result of that particular place, that particular box in the language processing realm, is that the tokens, a stream of token is passed to the next stage of language processing. Okay? It has not checked it whether it's okay or not. The only thing it does is to separate it. Now, in the next step, it's going to check for what? Syntax analysis. The order you use to present that thing, does it follow the laid down rule for that particular language? Are you with me? And so we look at syntax analysis, or in some places it is called parsing. Okay? Now, the purpose of syntax analysis is to check whether the arrangement, how those things, how the line of code, to check whether the arrangement of those tokens follow grammatical structure of that programming language. Are you getting me? To check whether if somebody can say age int equals, and when the system, when the let's go analyzer sees it, what is he going to? He's going to check it. Now, the order of processing in some languages will be like, we already stated that in our rules, the type has to come first. And so if you wrote the same thing, only that it was switched. Are you getting me? No. Now, when he looks at it, he says, okay, we don't have in our rule order, the type has to come first before the variable name. Are you with me? Now, when he checks it, if type has to come first as a laid down rule, now what we are seeing first is age. Now, the question is age a type of type? Do you understand what I mean now? In the database of types that we have for this language, is age included? If age is not included, it will now show you syntax error. Are you getting what I'm saying now? Why? But that language still has a type, but it was misplaced. Are you with me? Okay. So in this step, the syntax analyzer or parser takes the stream of tokens produced by the lexical analyzer and organizes them into a syntactical structure, often represented by a parse tree. And what is that parse tree? When you did binary search trees, we discover that you start evaluation from left. So maybe this is what you stated. You say, okay, what is supposed to come from the first angle is going to be the type. The next thing that we are going to find is going to be maybe the name, and the next thing is probably going to be, if at all we are going to find the next thing, it's probably going to be either semicolon or an operator. You know, there are languages that you may declare the variables without assigning a value to it at the initial point. Okay, so at that point, you can just say int age. You say that age is a variable, you end it there. Name is a variable, you end it there, and so on and so forth. But there are others that you can assign the variable. You assign value to the variable at the point of declaration. Are you getting it? So the system understands it that way. Is it this route you are following, or is this route that you're following? Whichever route you are following, it knows how to put those things in syntactical tree. Okay, this phase ensures that the code follows the correct sequence and structure of that language. Example, it will ensure that when you open a bracket, the moment it sees bracket opening, it's trying to see where you close the bracket. Are you getting me? So if you open a bracket and you did not close it, it's going to throw an error because that is what the rule says. The syntax rules are typically defined using context-free grammar, which dictate how tokens are combined. In other words, there are rules that is very specific to the language that shows how tokens are combined in this language. Now, when we talk about tokens, what do we mean? Let's refresh our mind. When we talk about tokens, what do we mean? Speak up, please. Yes, if you break that into smaller units, you have different tokens. What are those tokens? What can they be? Identifiers, operators. I just want to refresh your mind so that we won't just be talking grammar. So when we talk about token, your mind will quickly check it up. And when we talk about tokens, we mean keywords, variable names, identifiers, and so on and so forth. All right. The parser performs technique like recursive descent passing or left to right passing to build the structure tree. I think I've explained this. Now, the output of this particular box. You know, I'm using box because of that particular diagram I first presented. The output is a syntax tree or abstract syntax tree that represents the hierarchical structure of the code. This is then passed. That particular thing is then passed to the next stage. And what is that next stage? The next stage is to see this arrangement, does it have meaning? Do you understand? Semantic analysis. We want to check the meaning of these things that we are saying. Okay, does it have meaning, especially as it concerns the language that we are dealing with? So the reason for semantic analysis is actually to ensure that the syntactical correct code, remember, that code is already syntax free or syntax passed. The syntax has passed the check. So it will not generate error. All right? It will not generate syntax error. So by implication, it means that I may want to ask you a logical question. Explain why semantic error can appear before syntax error in language processing. Or I will say, I will just ask you a question to determine which one will come first. Are you getting what I'm saying? Now, what it means is that it is possible that your syntax will be correct, but that code will still not make meaning. Are you with me? It will still not make sense. Maybe, let's continue. Maybe there's a place I wrote something like an example that will help us to understand better. So the reason for semantic analysis is to ensure that the syntactical correct code has valid and meaningful semantics in the context of that programming language. And the analysis follows this step. Number one, during that phase, the semantic analyzer checks the program for semantic consistency. Okay? What you started from the beginning, is this still what is coming to the end? This involves verifying the program's constructs. This involves verifying that program construct makes a logical sense. So variables are those variables, are they properly declared before we start using them? Okay. Number two is operations. Are they applied to compatible types? Let's check, for instance. You declared a variable day of the week, and you declared it as a string. Are you getting me? Because you wanted to receive the day as a string, like Monday, Tuesday, Wednesday, Thursday. And then you now wanted to multiply that thing with how many days it appeared. Sorry, yeah, how many times it appeared in the year. Do you get what I mean now? Now, if you write the code, it will seem correct syntactically. Is that right? But semantically, it's not going to pass. Why is it not going to pass? You are actually trying to multiply a string with an integer, and it's not making sense. It's not making sense. Unless if there is a way you represented Monday to be 1, Tuesday to be 2. Now, you now know that when we see Monday, we regard it as 1. So if you now say you want to multiply how many times Monday appeared in 52 weeks of the year, you should be able to do that calculation because you have actually declared it to be integer instead of string. Another way is that maybe you want to add something to it. Are you getting me? Let's take, for instance, you placed an order on Monday, and we wanted to, and you declared Monday to be a string variable. Are you with me? And then you wanted to calculate to tell the person when the order will be due for delivery. And maybe you say it's going to be delivered in 10 days time. Now you needed to add 10 days to that particular day you are talking about in order to project when the date is going to be. Is it going to work? Because you cannot add 10 to a variable. It's possible it's going to work due to what is known as concatenation. But the thing is that it's not going to make sense. Are you getting what I'm saying? Now that brings us to semantics. And that semantics is like this thing that you are talking about now, is it making sense? That code is syntactically correct, but is it making sense? You see that actually the system is not going to throw any error at you, but it's still not going to make sense. It may bring about something. In fact, if care is not taken, you may be looking for where the error is because it has passed syntax check. Okay? Now, number 2, the analyzer examines the constructs like variable declaration, function calls, and type consistency. You declared this thing as integer before, and now you wanted to use it to perform string operation. Is it going to work? Okay? A symbol table is often maintained to track, the names. A symbol table is often maintained to track the names and their associated types, scope, and binaries. And 4, ensures that the operations involve compatible types, which is what I've been explaining now. That operation that you are applying to that identifier, is it compatible to the type of that identifier? Okay. Then the step 4 is that it verifies that variables and functions are used within their declared scope. Okay, are we together now? Now, you may have declared a private variable inside of a class, or rather inside of a method, and you want to use that variable outside of the class. Actually, that variable was declared, but it was not declared as a global variable. Are you getting me? So all these things are the things that the semantic analysis is checking to see, is it, this guy has tried, he has written a code that is syntactically correct, but that code, is it making sense? Is it going to give a required output? That is it. So the result of this, or rather the result from this phase, is an intermediate representation of code where semantic correctness is confirmed. So we say, okay, at this point, what you syntactically represented is actually semantically correct. Okay. Now we move into the next stage, which is code optimization. Are there ways that we can make this uh, intermediate code generation? Are there ways? Okay, yeah, intermediate code generation before code optimization. So when the semantic analysis, after the semantic analysis is performed, the operation is transformed into intermediate code that is simpler and closer to the machine instruction, but it still remains independent of the machine architecture. I'm not here to talk about computer architecture. So this intermediate presentation allows for further optimization before the final code is produced. What is optimization? How are we going to make this program better? How are we going to make it better? So in the phase of code optimization, the intermediate code is the code optimization is actually there to remove redundant calculations or even to simplify loops that you have actually written, but some of those loops may be too complex that it may take time to generate the output from that loop. Okay, so the code is optimized. After the code is optimized, the next thing now is that the code is now translated in such a way that the machine can understand it. When we talk about the machine, we are actually talking about your computer system. And we are using machines because your system, or rather the codes you are writing, may not necessarily work on your PC. Are you getting me? For instance, if you have written some embedded codes, you will discover that some of them may be working inside refrigerators, some of them inside televisions, some of them used in IoT works. Are you getting me? The important thing, I want to believe at this stage that you understand that this is not just the computer we are talking about. Okay, when we talk about the computer, we're actually talking about the CPU, the microcontroller unit. This is a piece of electronics, right? This is a piece of electronics. The thing that is happening inside of this system, the thing that you are seeing presently, is as a result of the processing going on in the processor. Are you getting me? And it's part of the CPU, the central processing unit. What I'm trying to say in essence is that your work can work maybe in an Arduino board, ESP 8266, and so on and so forth, Arduino Nano, different microcontroller units. You can be part of a team that may program the workings in an aeroplane. When you enter inside your car and you speak to Alexa and it regulates the temperature in your car, what is happening? You are giving input to the system, is taking it and responding to it based on the internal embeddings. So software engineering is very vast. You can work in the automotive industry, you can work in aviation, you can work in marine, you can work anywhere at all that electronics are situated. Are you getting me? Okay, so after that, you now see that the next thing is linking and loading. Here, the generated code is linked with the necessary libraries or other modules and then loaded into the memory for execution. Okay, any references to external libraries or functions at this point are resolved. Okay, and the final executable is prepared. Now, when it's prepared, it will come up as .exe file. Are you with me? Now, from the beginning point of you writing the code to the end point of building the code, you releasing a build. You release a build. This is what happens inside of the system. And you must need to understand that, okay, so that it will make your life easier, better. You know, you are better at what you fully understand. Okay, what you fully understand, you are better at it because it will give you rooms for manipulation. Are you getting me? When we were in secondary school, God so much helped us that there are some certain topics in mathematics that we were good at, and you can easily implement any method to solve it. Are you with me? Like in trigonometry, when you are looking for the maybe distance, you see trigonometry, you see bearing and distance, and you see triangles, the circle geometry, and some of those topics around these areas that I've mentioned. We were so good in them that you can just set one question. The thing that you are looking for is the answer. We can just import any method and use it to deliver the stuff and give it to you. Okay, so next we look at semantic versus syntax analysis. At this point, we are looking at the summary of them, and I want to believe that you can tell the difference even now, before now. In summary, while syntax analysis focuses on the structure of the code, that's the grammar itself as regards to code. Now, when we talk about syntax, remember, we are looking at the placement, the order of placement. For instance, you want to say Obi is a boy. Is a syntactically correct grammar in the English language, right? Now, these are the same things, but you cannot say Obi boy is a. You see, it's not really placed well. So, the order is it the subject, predicate, and the object? Okay? The subject, the predicate, and the object. That's the order in the English language. The how it is written. If I'm wrong, please bring me back. Correct me. So, in summary, why syntax analysis focuses on the structure of the code, ensuring that the arrangement of tokens is correct according to the language rules. Semantic analysis focuses on the meaning and logical consistency of the program, checking for issues like type mismatches, undeclared variables, and correct usage of scope. Correct usage of scope. Correct usage of scope. Okay, now we go to the next level. You know, when I was declaring the objectives of this class, what you are supposed to learn, the last part of it is naming and binding, right? So naming and binding are essential concepts in programming languages that govern how identifiers are associated with entities such as variables, functions, and objects during the execution of a program. How the names are associated with the values. Okay. Now, let's look at naming. Naming refers to the process of assigning a name or identifier to a program entity, such as the variable, function, constant, class, or module. These names make it easier for developers to either reference them. So you want to give the variable name to represent the name of the user. Okay, so whenever you want to call the user, you just call that name, right? Because it is supposed to hold the value of a name or a person, the name value of a person. Are you getting it? Okay. These names make it easier for developers to refer and to manipulate the underlying entities in the code. Naming convention and rules may vary from language to language, but the purpose is to make the code more readable. So, further explanation, you look at how these names are, how this naming are done in different languages. So, some languages will tell you that you can start with an underscore, upper or lower case name, lower case character, and you can also end it with a number. Are you getting me? But they will tell you that you cannot start with a number, something like that, or other symbols that is not underscore. So those are naming rules. And then there are others that some certain things, some certain convention will declare, will be used to identify the scope. I'm not quite sure, but I think when you declare, is it when you name a class with, when you are calling, is it in Python or so, where you want to call a subclass, the name of that class is going to come as an underscore, with an underscore before it when you are referring to it. I'm not quite sure. Now, when you look at the right side of the slide, you are going to see how these names are done. Assuming a name to a function is define calculation, or sorry, or is calculate underscore area, you see that you have the calculate area function that is written that way. Some will tell you that you use the camel case to name your variables and so on and so forth. And there is this other case. Who can remind me the other case? Yes. Okay. Okay, so then when you talk about binding, what do we now mean? Binding is the process of associating that names with entities, such as variables, function, objects, or types at various stages of the program. It defines when and how relationship between a name and an entity is established. It defines it defines when and how the relationship between a name and an entity is established. So there are basically two types of binding. You have the static binding and you have the dynamic binding. Let's look at them. When you talk about static binding, what do we mean? We mean that at the beginning point of that program, you have already established what that naming will become like. For instance, at the beginning point of the program, you are saying that my age is going to be declared as integer. Are you getting me? Now, that is static binding. It works at the compile time. Now, dynamic binding is what happens when you are already running the program. In other words, in dynamic typing, we don't really know the type of that variable until it starts running. Are you with me? We don't really know the type. You just declare it that way, meaning that the type can change during program execution. So dynamic binding is done at runtime. So what it means is that although you declared age equal to 10, the system is still seeing it as ordinary 10. Are you getting me? That age can change during program execution to become a type of string. Okay? They can still change. And that is dynamic. Maybe when you now start running the program and the system now sees that this thing is actually a string, it becomes a string for for the purpose, or rather for the time being of that program running on your system. So I don't know if I made sense here. Huh? So when you talk about dynamic binding and the static binding, we say that in static binding you are very strict that this thing cannot change. We want it to be this thing. It's not going to be able to change. Now, the other one is that we are establishing the type when the program is running. We want to establish it. Actually, we declared it as integer before because of the assignment. We have already assigned a value to it. So now, what is the difference between naming and binding? What is the difference between naming and binding? Now look at the features. This is what it does. It assigns a name to a construct. That's for naming. But binding assigns the name with a value or resource. Are you getting it? I declared the name. I did not connect it to anything. That is naming. But the moment I connect it to a particular value, it means that I'm binding it to that value. Are we together? Identifier is the name itself, while the binding talks about the relationship between the name and the entity it is bound to. All right. Now, this one is mostly syntactic. That's the naming. Why this one involves semantic processing, understanding what is actually happening with that, what is happening in the relationship between the name and the entity it is bound to. Then, an example is naming a variable like maybe int, or rather, what's it called? Maybe you want to, what's this? The one that gives you 0 point something, what is it called? Type. Double or float, depending on the, yes. So you say float total is just the naming, right? Now, but if you say float total equals to 200 points, this and that, it's binding. In other words, that name, you linked it with a value. Okay, then finally, we see the phases of binding in programming. I want you to look at this. Bindings can occur at different stages in programs' lifestyle. One, language definition, when the rules for names and constructs in the language are established. Okay. Number two, at compile time, which I've stated something about it, when variables and functions are associated with particular memory locations or types during compilation. At link time, when external functions or libraries are linked to the main program before execution, that's when a binding can also actually occur too. At load time, okay, are you supposed to be in this class? I don't know you. You are aspiring to the experience. From which party are you? See this guy, go and sit down. Okay, at load time, when variables and entities are located memory just before the program starts execution, binding can occur at that time. And finally, binding occurs at runtime when variables are associated with values or objects dynamically as the program runs. Okay, I don't know if you have any questions at this point before we enter the other class, the next class.